Here's some questions that are similar to ones that might be found in a trigonometry test. The first one is a proof question. Now, all proof questions, we have to start with LHS, left-hand side, which is here 2 cos squared theta minus 1. Always have to start with the left-hand side to try and get to the right-hand side. Now, key to this one is we've got a cos squared and a sine squared. That gives us a hint that we need to use one of our trigonometric identities, the Pythagorean identity. That says that sine squared theta plus cos squared theta is equal to 1. Now, because we want to get rid of that cos squared and turn it into a sine squared, we can just write cos squared theta equals 1 minus sine squared theta. And this is the sort of working out that you'd expect if you answer this question. So, replacing that, we get left hand side is now 2 brackets 1 minus sine squared theta minus 1, which is equal to 2 minus 2 sine squared theta minus 1, which is equal to 1 minus 2 sine squared theta, which is our original equation, which equals RHS. So we have to remember to always start with left hand side and move to right hand side. Now our second question is a bearings question, and we always have to be very careful with bearings questions. So we want to explain why PQR, so that's this angle here, is equal to 100 degrees. And we're going to have to use some of our Year 7 geometry here. Firstly, we know that the angle here is co-interior to this angle here. So, we can say that, let's label this north and north dash. So, we can say that angle north dash QP is equal to 180 minus 50, or in other words 130 degrees. The reason being co-interior angles are supplementary on parallel lines. Now that we know that angle is 130, angle PQR is going to be 360 degrees minus the two 130s we already have. So that's 360 minus 260, which is 100 degrees. Again, the reasons is angle around a point, sum to 360 degrees. So the rest of the question is not what I'm going to answer today, but it's going to involve your sine and cosine rules, distance between ports R and P. Okay, well, you've got one angle here, one side here, so it's going to be a cosine rule. And find the bearing of port R from port P. Okay, I'm just going to give you a clue with this one. You're going to you have the north here, so you're going to have to find this angle here to find the bearing. Okay, because the degrees from north. Which means that you need to find this angle over here. Now, if you've there are two ways of doing it, but they both involve the sine rule. Okay, either using the sine rule, and they all involve what you found in Puppy.